Hello students and welcome back to my YouTube channel. In today's video we are going to go over the structures of the sarcomere. Right off the bat I want you to know that the boundary between one sarcomere and the next is being done by this Z line. So the Z line is going to be the boundary that separates one sarcomere, which is the functional unit of your muscle, to the next sarcomere. So that is the boundary. I want you to take a look at this pink color. That pink color is representing your thin filament. That's called your actin. So your actin is your thin filament. And then we have this thicker filament in purple, and that's called your myosin. Okay, so your myosin is your thick and your actin is your thin filament. Take a look how actin is being anchored to the Z line via this protein that is called titin. So titin is going to anchor the actin or the thin filament to the Z line. Okay, what anchors the myosin or the thick filament? That's called the M line. So the M line is responsible to anchor the thick filament, while we have titin anchoring the actin filament to the Z line. All right. So now, let's talk about some bands. You have two bands that you're responsible to know. If I were to draw somewhat of a dotted line right here, and I want you to take a look. Okay, so this area, the area, and I'm just going to go from here to here. The area that does not include, and take a look, I'm going to make a line. The area that includes your Z line, the titin, and the actin is called the I band. Okay, I'll repeat that again. The area that includes your Z line, the titin, and the actin is called the I band. The I band is going to appear lighter in color. So lighter. I for lighter. And the reason is because you only have your thin filaments, which is your actin. But what about the band that includes, the darker one? That is called the A band. So the A band is going to start here. It's going to start here. And it's going to go all the way through, and take a look. Going to go all the way through up to about here. Okay, and so that's called the A band. And so the A band is darker. Okay, are you following? A in darker, I in lighter. It appears darker in color because of two reasons. The number one reason is the zone of overlap. And you might ask yourself, well, what is the zone of overlap? The zone of overlap is going to include actin and myosin. So this is myosin, actin, and that's why it's called the zone of overlap. Okay, and so the A band is going to include one, the zone of overlap, and it's also going to include the H band. And the H band, and I'm just going to go, I guess, down here. The H band is going to be the area of where we only have myosin. So the H band is the area where we only have myosin. Okay? So we talked about the I band being lighter in color, and we have the A band being darker in color. The A band includes the zone of overlap, which includes the actin and myosin, and it also includes the H band, which only includes myosin. And we talked about the M line, which is going to anchor those thick filaments. It's going to anchor those myosin proteins. All right, so now, what is next? Let's talk about contraction. And I am going to elaborate another drawing. So far, so good. All right, so now let's take a look at contraction, and I'm going to zoom in at this region right here. We're going to look at the actin and also the myosin with its myosin head. I'm going to draw it right here. So this is your actin, right? I just blew it up, and instead of being this line, I zoomed in on that line, and you can see all of this little kind of like spherical shaped structures. These are called G proteins. So all of these are your G proteins, okay? Now, each G protein is going to have an active site. And this active site of the G protein is going to allow for the myosin head, and I'm just going to draw it here, for the myosin head to, take a look, interlock right there, okay? However, it's not that easy because the active sites are being covered, and I'm just going to draw this right here. They are being covered by this protein that is called the tropomyosin. Okay, so that tropomyosin is that covering of the active sites that are found in the G protein. In addition to that, you also have these other proteins which are going to lock the tropomyosin in place. Okay, now how do we remove these lock-shaped structures? And these lock-shaped structures are called your troponin. So troponin are those like structures that are going to anchor the tropomyosin on top of the active sites. Now, when a contraction occurs, you need the presence of the calcium ion, which is going to come here and bind with the troponin, okay? After calcium binds with the troponin, then troponin is going to remove, which is then it's going to cause the tropomyosin to kind of move away. So it's going to move away, and it's going to move away, and it's going to, take a look, expose those active sites. Now we can have the myosin head interlock with those active sites, okay? And now these myosin heads are going to kind of pull in that direction, and it's going to shorten the sarcomere. All right, so as a recap, let's talk about the actin. The actin is going to be composed of the G proteins. The G proteins have the active site, and the active site, that's the place where the myosin heads come in contact. However, the active sites of the G proteins are going to be covered by this sheath, if you want to see it that way, this sheath, this protein sheath, and that is called the tropomyosin. So the tropomyosin is going to cover the active site, and the tropomyosin is being held in place by these proteins that are called the troponin. And again, we can only remove troponin by the presence of the calcium ion. I hope that this video cleared some things up for you, and I wish you the best of luck during your examination.